Good afternoon, everyone. Today we're going to do a video on comparing ratios, and this will be out of the grade 8 math curriculum. So here's our situation. We have Alex that runs 12 laps in 8 minutes, while Connor runs 20 laps in 12 minutes. And so we're being asked to find out who is the fastest, okay? So my recommendation for a problem like this is to use rates and then to compare those rates. Let's start off with Alex. Alex is running 12 laps, and so we can write this as a rate of 12 laps per 8 minutes, okay? Next off, we have Connor running 20 laps in 12 minutes, and so we can write that down as a rate of 20 laps in 12 minutes. Now, to figure out who's the fastest, we simply want to compare the two rates and figure out who's running more laps in a given number of minutes, right? Now we can use any different given number of minutes. We simply have to get the same number of minutes in both rates so that it's easy to compare who ran the most laps. We can't compare laps if they're running different amounts of minutes, right? We have to get the same amount of minutes, however we choose to do so we can compare the number of laps. Alternatively, we could also equate the number of laps that they run and simply look at who ran for the least amount of time. That would also tell us who's running the fastest, right? If you run the same distance but use less time, clearly you're running faster. And so we have many different strategies to compare these two rates and figure out who's fastest. I'm just gonna offer you guys a few suggestions and you can pick whichever one you prefer, okay? Let's go off and look at the same number of minutes. You might look at 8 and 12 and think, well, 4 is a nice factor of both numbers, so we could bring both of these down to 4. How about we do that first? So to bring 8 down to 4, we'll have to divide by 2, and to keep our rates equivalent, we have to divide both sides by the same value. Now for the 12, to get it down to 4 minutes, we'll divide by 3, and again, to keep our rates equivalent, we'll divide 20 by 3 as well. Now, 12 divided by 2 will give us 6 laps per 4 minutes, 6 laps per 4 minutes for Alex. And for Connor, we'll have 20 divided by 3. That is 6.7 laps. I'm rounding up. We have 6.6 repeating. I'm rounding up to 1 decimal place. So 6.7 laps per 4 minutes. Okay? And so right away, with simply this amount of work, we can see already that for the same number of minutes, Connor runs more laps. And so clearly, Connor is the faster runner. Okay? However, I just wanted to show you that this is not the only strategy. There's so many different strategies to compare these ratios, these rates, right? We could have done per 1 minute for both rates, right? We could have found their speed per minute, like laps per minute. So to do that, we could have divided the first rate by 8, and we would have found 12 divided by 8 gives you 1.5 laps per, and clearly 8 divided by 8 gives you per minute, right? If we had done the same with Connor, to get per minute, we're gonna have to divide by 12, and so dividing by 12 would also give us his rate per minute, and so now per minute, we would have 20 divided by 12, which is 1.7 laps. Let me write that in a nicer fashion. 1.7 laps per minute. So this would be his unit rate. And so comparing unit rates now, Connor's unit rate is 1.7 laps per minute, Alex's unit rate is 1.5 laps per minute. Again, clearly coming to the same conclusion as we came to in our first strategy, Connor is the faster runner. Okay, we could use a different strategy. We could find how many minutes it takes to run 1 lap. We could equate the number of laps and figure out who used the least amount of minutes. Let's do that just for the sake to say that we did. What's the smallest number that is a multiple of both 12 and 20? This would be analogous to finding a common denominator to work with fractions, for those of you that remember how to do that. The smallest number that's a multiple of 12 and 20 happens to be 60, right? So if we can get 60 laps and 60 laps, then we can figure out who is the fastest based on who takes the least amount of time to run those 60 laps, right? Now to get down to 60 laps, we'll have to multiply Alex's 12 laps by 5, right? 12 times 5 would give us 60 laps. And so to get an equivalent rate for Alex, again, we have Alex first and we have Connor below. 12 times 5 brings us to 60 laps. And so 8 minutes times 5 gives us a time of 40 minutes to run those 60 laps, right? At this rate, he's gonna run 60 laps in 40 minutes. Likewise, Connor would require 20 laps times a factor of 3 to get 60 laps in. And so to keep our rates equivalent, we're gonna multiply the 12 minutes by 3 as well. And 12 minutes times 3 would give us a time of 36 minutes, okay? And so again, we see that in this case, Connor ran the same number of laps, namely 60 laps, but he used a smaller number of minutes. So he did them faster, right? And so again, we come to the same conclusion. Connor is the faster runner. Okay, so whenever we're comparing ratios, comparing rates, we always want to stabilize the rate or the ratio by finding the same value on either side. As long as we get the same value on one of the sides, whether it be the first side or whether it be the second side, we just need the same value on one of the sides, and then we can compare the ratios by the difference in the values on the other side. And so I hope this was helpful. Again, if you guys have any comments, suggestions, requests for future videos, always appreciated, and thanks for watching.